It seems everybody today is talking about the cloud. But what is the cloud? The cloud can be defined as a model for offering on-demand, convenient access to a shared pool of configurable resources. For example, networks, servers, storage, applications, and services that can be then rapidly provisioned and released with minimal management effort or service provider interaction. This comes from both NIST and the Cloud Security Alliance. The idea of the cloud really is not new. The cloud is quite simply an evolution from what we used to do when we did remote data hosting on a mainframe, for example. The idea of a mainframe very often was that it was a shared pool of resources used by a number of different vendors. And the ability of those customers to be able to then gain access to the storage, the processing, the bandwidth they needed was very often tightly regulated then by contracts. In today's world, we can often add on the resources we need with almost no type of interaction even with a cloud provider. That allows us to pay for what we use. That allows us in many cases to add on bandwidth, add on storage, add on processing power during peak times and only pay for what we use rather than having to buy equipment that will meet our peak demands but then paying for that all year long. So the idea is that all of these resources can be provisioned but also can be released without having to go through all sorts of negotiations with the cloud provider. There are a couple of different cloud computing service models, and they're all very different. The foundational model is infrastructure as a service. Infrastructure as a service is used to provide the platform that our organization may run on. The cloud provider manages the networks, the end user devices, manages, we could say, all of that underlying IT infrastructure on our behalf. This actually puts all of our IT operations, therefore, into the hands of that, third party. And many organizations have done this in the past. It's just now that, almost everything is becoming this term as a service. This service and this type of service has been available for years, and it certainly has continued in the cloud computing model. Another type of service model is then platform as a service. Let's say, for example, I need a SQL database. Instead of me going and buying and hosting a SQL database, I can go to a company that actually does have SQL and then just rent from them, if you will, the space on their system. So they're providing that platform that I can then now deploy my own customer created or in some cases acquired applications. I may go and buy an application I run on top of that platform provided by the cloud provider, or it may be an application we wrote ourselves. And then we have products like software as a service. Software as a service is one of the ones we would think most traditionally in the world of web and cloud providing. Because what do we have here? We actually have with software as a service that the service provider is hosting an application. We can log into that application very often with just a cheap browser or a tablet. We actually are using the application running on the service provider's cloud infrastructure, and that allows us to easily be able to provide access to people without a large investment in personal computers. Anybody can log in just with a simple browser. The advantage of software as a service is that if the software service provider needs to do an upgrade and a patch, once they apply that patch, every customer who accesses the software as a service provider systems will then benefit from that patch. It's not like where you have to roll out the patch to all of the devices on our networks, for example. There are a couple of different cloud computing deployment models as well in use. The most, should we say, recognizable would be a private cloud. A private cloud is really a server room for my own use. That may be on my own premises, or it may be that another company is actually hosting that equipment for me. But that is for my own personal use, and therefore nobody else is able to use it. So as we see, either operated on-site or off-site solely for the benefit of the client. We then have community clouds. A number of universities and other organizations use these. They are a shared service shared by several organizations who then collaborate and work together. Where, for example, one university might host the data center and all of the other universities just connect to that. It gives them a place for, in this case, educational institutions, companies of a similar type of nature, will be now able to work together and collaborate and possibly have a lot of savings as well. You take, for example, if we're going to host one data center that might support the data center needs for 5 different universities. That means in one data center, we have one power plant, one heating and ventilation and air conditioning system. We have, of course, everything that's necessary in one place. That may be a significant one, savings on environmental impact, as well as savings then on financial impact, because we then combine all of those services together, so they don't have to be then managed individually. Many of us have used a public cloud. Services available to the general public, such as email services, such as documents sharing services, and public cloud services certainly are something that a number of organizations have looked at as well for things like their email and so on. The challenge, of course, is that this is available to the general public. It's not always as well protected, for example, as a private cloud. In most cases, a public cloud is going to be hosted off-site at the data center of the cloud provider. But many organizations will use a little bit of both. Maybe a public cloud for some services and a private cloud for others. And this idea, of course, of a hybrid can very often help us by combining 2 or more of the cloud models. I may be able to provide additional support for then my own systems. We can say here through the expertise that's available and leveraging in many cases the knowledge we have. The thing is that through using the cloud, we're often able to be very rapidly flexible and going to be able to, in many cases, meet changing business requirements. All of a sudden, if we have a tremendous upsurge in data storage or processing, we can actually accommodate that through the agreements we have. These are often called cloud bursting types of techniques. And we also can try to ensure we have load balancing between our various systems. So what makes a cloud? The essential characteristics of cloud service is something we looked at before: rapidly provisioned and rapidly released. It is all about providing on-demand self-service, so the client can obtain that additional bandwidth and storage they need at their own request without having to go through the vendor. Another characteristic of cloud service is to provide broad network access. Through broad network access, we can ensure that the various clients are going to be able to have very good communication rates. We pool our resources. We mentioned a moment ago pooling things like heating, ventilation, air conditioning, power plants. And so this type of pooling can certainly provide significant savings in environmental costs, as well as, of course, the overall maintenance of the system. The thing is, the cloud should be very flexible, and a good cloud services model practices rapid elasticity. We can easily add on and take away. We can easily adjust to changing business needs. And finally, one of the most important parts of cloud services is that you pay for what you use. It is a measured service, and so an organization that is then using the cloud knows that they will be charged only for what they are currently using, not charged for all sorts of spare capacity that they might be holding on to in case they would need it on a peak day, for example.